In this video, we're going to cover a second standard access list activity, and we've got a network here. Basically, we have 4 different networks that we are all connected to via one router, and we've got a couple of goals up here up at the top. First goal is to block PCA from accessing the server network. So if this is PCA right here, and this is the server network right here, then that means we want PCA to try to access the server network but fail. The very next line in here says allow everything else to access the server network. So even though PCA is being blocked, we want everybody else, including PCB, to successfully access the server network. All right, so that should be a piece of cake. We got two line items there, both having to do with securing the server network. Awesome. Very last block in here says block the 192.168.1.0 network from being accessed by 192.168.3.0. So we've got this network down here. It is trying to access this network and it should be blocked. However, even though it doesn't say it, it's implied all of these other networks should be able to access that VLAN as well. So let's look at this a little bit here. We can break it down into 2 different chunks. We've got the first 2 as one chunk and then the third item as the third chunk. And so we will work with these as that. Now, when we're talking about access lists, there's a couple of things we need to focus on as we're dealing with them. The first one is that there is an implicit deny. As soon as you create an access list and apply it to an interface, there's an implicit deny at the very, very end of that access list, which means you don't necessarily always have to include a deny. It's just always going to be there. That also means that if you don't allow a permit, then the deny is going to take over after that. The second thing to talk about when we're talking about access lists is that these are top-down. When we start putting access lists in, the order that we type in the access lists are going to matter, because the very first line item or the very first item that matches in that access list will go into effect, whether that's a permit or a deny, and therefore we have to put these in the correct order for them to work properly. The reason why I'm saying that, well, let's say I put in this allow first with these 2 commands here. If I say allow all, or permit all, and then after that I say deny or block PCA, well, we start from a top-down method. This allow all is going to say everybody is allowed, and then after the fact we're going to say except you, but that person's already gone through the gate. They've already made it into the party, and so you can't just explicitly block out one person after you've made the statement that everybody is allowed in. So we would have to actually be careful and change the order of these and put the block before the allow for everybody to work properly. So let's go ahead and start doing this. Let's fire up an Excel spreadsheet here. And we have, let's see, permit / deny, source IP address, interface, direction, and then I'm also going to type in a rule name. What do we want to call these rules? I put in the rule name simply because, well, we've got lots of, it helps us organize things a whole lot easier. So let's just look at these first 2 line items here, since they both have to do with the server network. First thing we want to do is we want to block PCA from the server network. So let's go ahead and put in a deny. The source, PCA is 192.168.1.10. We'll talk about the interface here and just interface and direction in just a moment. And then the rule name, well, we're talking about the server network, so I'm going to just call this protect servers. It could be any name that you want to put in there. In fact, it could even be a number, standard access lists 1 through 99. I like the names because they're more descriptive. The second line item here is allow everything else to the server network. So in that case, I'm just going to put a permit. Oops. Permit. In this case, the source is any, and it's the same rule, protect servers. Now there is, like I said, there is an implicit deny right down here at the very end. However, because I'm doing a permit any, this implicit deny doesn't really do anything. If I'm saying everything is allowed and then I say everything is denied, I've already allowed everything in. Therefore, the deny doesn't really do much. Okay, so let's look at this. We've got a top-down order. So we look at this first guy. We are denying this one specific person from entering into our party. The one guy that we don't want in our party because he talks about weird things. We are specifically excluding him, and then we turn to the rest of the crowd out in the parking lot and we say everybody else is allowed into this party. And that pretty much is these first two lines right here of our protect servers rule. Awesome. The only questions now is which interface and which directions on those interfaces do we put those? Well, let's look back at our diagram here. We've got 4 interfaces. We've got an interface that protects this network. Oops. We've got an interface that's for this network, an interface for that network, and then an interface for the server network. And so what we want to do is, as we're looking at these guys, we want to say which interface is common for all of these rules, all of these access lists that we just wrote, all 2 access lists that we just wrote. And as we look through all these interfaces, even though this is the one that we're specifically blocking things on, everything else is going through this interface. So we probably want to put this rule on interface E1-3. So we'll put that E1-3. And then the question is, which direction is the traffic coming? And this is where we have to think about the flows. We are specifically saying we want PCA not to access the server network. We're saying we don't want PCA to send data to the server network. We're not saying anything about the server network sending data back. So in that case, we know that we want to block one flow. We want to block this traffic from going into the server network, but we're not saying anything about the server network sending any traffic back. We may in the future, but right now we're only concerned with one direction of the flow. Great, so that makes life a little bit easier. We now look at the traffic from this router's point of view. If the traffic is going this way, from the router and the interface's point of view, the traffic is now flowing out of that interface. Therefore, we're putting it on this interface and an outbound traffic. Hopefully that makes sense. So we come back here and we say our direction is outbound. Perfect. We have now created 2 lists or two rules in an access list called protect servers, and we know which router to put them on. Which interface to put them on, and our permits and our denies, and everything should be perfect. At that point, in order to actually implement this, it is simply a matter of converting this idea or these tuples right here into the Cisco specific access lists. So let's try it. Let's see if it works. First off, I've got my packet tracer right here. I have gone ahead and I've configured the IP addresses. Apparently clear does not work in packet tracer. Just as an example, I'm going to try to ping everything. So I'm going to ping 172.31.1.10 just to see if all the IPs are configured and if things are routing properly. And so far it looks like they are. 192.168.2.10 to ping the network in blue there. And then 3.10 to ping the network in pink. So traffic is going out from PCA and pretty much coming back to everything from everywhere else. So our router is configured, our IP addresses are configured, there's no access lists currently. So now we go into the router and we start creating our access lists. So if we look back at our spreadsheet here, we want we want to create a rule called protect servers. It's going to be a standard access list. And then we're going to put these two rules on there. All right, so IP, specifically for Cisco, IP access list standard. Tab complete comes in really handy here. Tab complete and the question mark, actually. And then what name do we want to call it? We want to call it protect servers. Awesome. So now we start putting these in the order they are. It is a deny question mark just to make sure. Here we want to block one specific host. So not any, excuse me, host. One specific host. So we can actually type in the command or the keyword host. And then question mark, and now we type in the specific IP address, which is 192.168.1.10. Because this is a standard access list, if I hit question mark again, that's it. It's only the sources that we're dealing with. So I have my deny. I still have an implicit deny at the very end, so I do need to actually include in that permit. So permit, again, question mark. I look here. It was not one specific host at this point. It's not even a network. It is specifically any that we're looking for. So permit any. That's it. And that is pretty much my protect servers rule. So at this point, I now go to interface E1.3, excuse me. I apply the protect servers rule in an outbound fashion. Int E13, IP access group. Tab complete comes in really handy here because I remember it's IP access something. And it fills out access group for me. Here I have to do the name. As always, the name is case sensitive. So if I come up here, I can copy this, copy, and then paste. Question mark then tells me inbound or outbound. In this case, it is outbound traffic. And enter. All right, let's see if that worked. That was the whole purpose of having this packet tracer, is to actually take what we've come up with in our spreadsheet and test to see if they are working. So first off, let's see if my deny works. Ping 172.31.110, and I have destination host unreachable. So the router is actually calling back and saying, nope, you can't get there. I should still be able to ping everybody else, however. So if I now try to ping down to the pink network there, it's working just fine. That was PCA. PCB should still be able to access the server network, however, because we only... So ping 172.31.1.10, and it goes right on through. So we did it. We blocked PCA from accessing the server network in yellow, and yet PCA can still access everything else. Everything else can still access the server network. We blocked out one specific host. Perfect. All right, so we've gone ahead, we've done that, and we've done that with an access list called Protect Servers. Yay! Now we're on to the third bullet point. We want to block our 192.168.1.0 network from being accessed by 3.0. Might take you a couple of times reading that through to make sure you understand the direction properly. Basically, we want to protect that network from this network. So this network is trying to come up here and access that network, and it should not. And it is implied that the other networks should succeed. All right. So in that case, we are going to create a new network or new access list. Let's go back to our spreadsheet here. Again, we're in a top-down format, so we want to start off with denying one specific person or one specific group of people. We don't want any weirdos in our party. Or maybe we're the weirdos and we don't want any normies in our party. I don't know. So we're going to start off with a deny. And who are we denying? Well, we are denying that bottom network, 192.168.3.0 /24, because we want to block the entire network. Interface and direction we'll talk about later. Rule name, for lack of a better term, I'm just going to call this protect 192.168.1.0. For lack of a better name. I see. Does that packet tracer have a different name? No, packet tracer does not have a name for the network, so we'll leave it at that. All right, so we are now denying one specific network from accessing another network. Just as we denied a specific host, we're now denying a specific network, but we want everybody else in. So just like we did before, now we do a permit. Any. Same thing, protect 192.168.1.0. Great, so now the question is, which interface and which direction do we put these on? Well, let's again look at our flows. We've got this guy right here, which is being denied. We don't want him to access it. We then have this guy, which should succeed, and this guy, which should succeed. If we look at all the networks that are, or all the interfaces that are in use in this access list, we have one interface which is common for all of them, which is this E10. So we now know that we want to put our access list on interface E1-0 because that's the one that allows us to permit or deny all of our rules. So E1-0. And then again, the direction, what direction do we want it to be? If we're looking from this interface's point of view, coming from the router, we are blocking traffic from going that way. So from the router's point of view, it is an outbound traffic. Remember, we are blocking access to this network from this network. That doesn't mean that the network can't talk back. That should be able to succeed. It's just that way that should fail. So E10, outbound traffic. And now we should be able to just simply create our access list, apply it to the interface, and test to make sure that it's working. So let's open up our router again. Put our spreadsheet right next to it so we can see what we're doing. And let's create an access list. IP access list, standard, and we want to call this protect 192.168.1.0. Again, name it whatever you want. That's a fairly descriptive name. It allows me to quickly see what it is that it's doing. Again, looking at our rules, it's a top-down process, so we're going to start off with our deny. Looking at our options here, we have a specific address, a specific any or a specific host address. We want to actually match a network. So we're going to go ahead and start off with the IPs. So 192.168.3.0, and now question mark again, and it says here, what is your wildcard bits? Because you want to block an entire network, we then now have to specify how big that network is. In this case, it's a class C or /24. We have to remember that this is a wildcard. Another caveat that we have to worry about with Cisco devices, wildcards are opposite of what our normal subnet masks are. In this case, if our mask is 255.255.255.0, which is a class C, that means our wildcard mask is 0.0.0.255. Takes you all the way back to the binary. All of your ones that were in your mask turned to zeros, and all your zeros turned into ones for your wildcard. Why Cisco did this, I'm sure it made sense 20 years ago. We're now stuck with it today. So we want to go ahead and type in that wildcard mask. And now we have our deny statement right there. Now we just need a permit any, and our access list is ready. Now we just need to go to our interface E1-0 and assign it outbound. So IP access group, access list, access group, type access, hit tab. Protect 192.168.1.0 and outbound. And now we confirm if everything is working properly. So at this point, PCD should not be able to ping PCA. 192.168.1.10, and we get a destination host unreachable. Same thing with PCB. Destination host unreachable. However, going to PCC 192.168.2.10 should succeed. Now, the interesting thing here is this is where some of these error messages start coming in handy. Here we see that PCD was not able to access PCB. And it specifically returns back the message destination host unreachable. So the router specifically said you don't have access to that network. If we go the other way around, if we go to B and we try to ping D, so ping 192.168.3.10, you'll notice that we get a different error message, and this time it should be a timeout. Want to make sure it continues to time out. There we go. So what's happening? When we go from PCD on up to PCA, what's happening is we're going this way, and the router says no. And it specifically returns back an error message saying, no, you can't do that. What's happening when we go the other way is PCB is coming down, and it is making it all the way down to PCD. And this is where the data flows come in interesting and handy to understand exactly what's happening. So the echo request is making it all the way down to PCD. PCD, however, then sends back a response. And what does the router say? The router says no. So that's why we're getting a timeout, because the router's actually allowing the request to go through, and then it's blocking the response. So there you have it. There is our second access list activity, our second standard access list activity. If we actually look at the rules now, and again, the rules are kind of secondary. I'm more concerned with making sure we understand the access lists and the tuples that are associated with them. If we do a show run here, then we can see interface E10 has an access list applied, or an access group, and E3 has an access group applied as well. And then when we look at those access groups, again, we start from the top down. So we go this way. We start off by saying, you are not allowed into our party. Everybody else is. You are not allowed. Everybody else is.